Okay, in this video we're going to continue using the shell method, but now we're going to rotate our region about a horizontal line like the x-axis. And so I have the region underneath the square root of x from 0 to 1, and I am going to rotate this about the x-axis, which is going to give me this solid region here. And again, I want to think about this as being a three-dimensional shape. Okay. And I'm going to use shells here. So using a shell here, my rectangles that I would stack using a shell would be rectangles that are oriented horizontally, right? If I oriented my rectangles vertically and I rotated them, I would end up with a disk, right? So a rectangle going this way, rotated around, would give me a disk, and I could simply use the disk method to solve this. But if we have these rectangles oriented horizontally, and we stack all these shells inside of each other, then we're going to get a bunch of shells stacked inside. Okay, and so that's just one of the shells. Again, you have a lot more shells than that, but that's what they look like. And so if we're going to set up our integral here, I want to think about, first of all, where would my shells, or where would my rectangles be before I rotated this region? So my rectangles would need to be going horizontally, like we said, and that means that they would go from a y value to another y value, not from an x value to an x value. So these are going to go from y equals 0 to y equals 1. And because of that, I need to make sure that my function is determined in terms of y as well, so that, because I'm integrating with respect to y, and these 0 to 1, these are not x values, these are y values. Okay, so I'm going to have 2 pi times the radius of each one of these shells. So what would the radius of this shell be? Well, I would go from the x-axis up to whatever y value I'm determining my shell at, right? So it has nothing to do with what the function is. It's only what is my y value. That's going to be my radius. So this is going to be y. The height of each shell, is always, in this case, going to be, so here is the right part of my rectangle of each one of these is determined by the line x equals 1, right? So that's always going to be the height. But then if I go down to where the bottom of the rectangle is going to be, that's always determined by this other function, which is the square root of x. However, since I want this in terms of y, I need to square both sides here, and I need to think of this as being x equals y squared. But my height of my rectangle is always going to be from 1 to where that function is at. And the way that I do that, the way I say this is, it's going to be 1. So the distance 1 means from here all the way out to 1. That's what that means. The distance to the function is from here to the function. So if I take the distance to 1 and I subtract away the distance to the function, I have the distance in between the function and 1, which is where my rectangles would be. So this needs to be 1 minus the function, and again in terms of y is y squared, and then dy. Okay, so the height's a little bit different there. It's a little more complex to come up with that than what it was on the last example. But it's always, think about where the height of the rectangle is determined, the rightmost part of that, and then where the leftmost part of that is determined, and that will give you this height of 1 minus y squared. So distribute your y, and then we're ready to integrate. So 2 pi integral from 0 to 1 of y minus y cubed dy. And then we can go ahead and integrate, and so that's going to be 1/2 y squared minus 1/4 y to the 4th, and I'm going to evaluate that from 0 to 1. When we plug in 1, we get 1/2 minus 1/4. When we plug in 0 to all that, we get 0. And so 2 pi times 1/2 minus 1/4 is 1/4. And multiply that by 2 pi, I get pi over 2. Okay, this is a case where using disks is probably a lot easier. It is a lot easier because, and we did this problem as well in the video on disks. Using a disk, my rectangle is oriented vertically, which means I'm going to get circles, and the radius of those circles is just going to be determined by y equals the square root of x. And so I would simply just have the integral from 0 to 1 of pi times square root of x squared. And that integral is much easier to deal with than this. Now this one's not difficult, but using disks and stacking them from x equals 0 to x equals 1 is the same as using shells and stacking them from y equals 0 to y equals 1. I would get the same exact volume in that case. So just like okay, so with shells, if we go about a horizontal line like the x-axis, my shells need to be determined in terms of y, whereas the discs or the washers, if we rotate those about a horizontal line, those are in terms of x. And then that switches for vertical lines. So if I rotate a region about a vertical line using a disc or washer, it needs to be in terms of y, and using a shell, it needs to be in terms of x. So a lot of times that will help you determine which method is going to be easier for you, because again, remember, they are oftentimes interchangeable and you can do either one.